Okay, second lesson here is using how to use trigonometry to find the sides of triangles. So the main use of trig in the real world is instead of measuring all three sides of a triangle, if we can measure one side at an angle using the sine, the cosine, and the tangent, we can actually figure out what the other two sides are without actually having to physically measure. That's really useful if, let's say, you're measuring the height of a building. If you measure your distance from the building and the angle to the top, you can actually measure the height of the building without having to physically run a meter stick all the way up the building. So the way to do it though, which one you use depends on the sides you know and which angle you know. So that's why we had to label the sides yesterday. So the hypotenuse, the adjacent, and the opposite, because you use a different ratio on your calculator based on which one you've got. So if you know the hypotenuse and the opposite, if you know these two sides, opposite over hypotenuse, you're going to use the sine. If you know the adjacent and the hypotenuse, you're going to use the cosine. If you know the opposite and the adjacent, you're going to use the tangent. By the way, there's a trick to remember that. It's called SOHCAHTOA. So, sine opposite hypotenuse, CA, cosine adjacent hypotenuse, and TOA, tangent opposite adjacent. So this is probably the trickiest part, is figuring out which one you have to use. Fortunately for you guys, you're always going to have access to being able to look this up when you're doing this in the course, the benefit of it being online. You can even have this little chart beside you when you're writing the tests. So the steps for the opposite and the hypotenuse. So there's two things you could find. We could either ask you to find we could give you the hypotenuse and say find the opposite side, or we could give you the opposite side and say find the hypotenuse. So the reason I've got it written out like this is so that as you're writing, you can go back and you can basically see exactly what you have to do. So you have to write up the equation, you cross multiply, and that gives you what the opposite side is. So when you're doing this, to find the opposite side, you multiply the hypotenuse by the sine of the angle to get the length of the opposite side. So you just put in the number for the hypotenuse, put in sine, and then the number of the angle, hit equals, and it'll tell you what the height of the opposite side is. If you're finding the hypotenuse, if you'll notice, after you cross multiply, you would have to divide by the sine of the angle to get the hypotenuse. So to find the hypotenuse, you divide, if you know the opposite side, you divide the opposite by the sine of the angle, and that gives you the length. Now, this may sound Greek to you right now. In fact, theta is Greek. It's one of those skills you just have to practice and just remember, do it until it sort of becomes natural. But this will always work. So if you know the opposite and want to find the hypotenuse, you multiply the hypotenuse by the sine of the angle. You don't need to do all this rearranging. I only need to see this step, by the way. This is just in case you forget. You can actually figure it out yourself by rearranging. Also, it's kind of nice to know where it comes from. If you know the opposite and want to find the hypotenuse, you divide the opposite by the sine of the angle to get the length of the hypotenuse. So let me show you how that's done. So let's say I give you a triangle and like this. The hypotenuse is the side opposite the right angle. So we know the hypotenuse, we know the angle, and we know the side, we want to know the side opposite. So this is the first case. We want to know the opposite, we know the hypotenuse. So because it's opposite and hypotenuse, we know we're using sine. So to find it, we multiply the hypotenuse by the sine of the angle. So 15 times the sine of 53. You put that through a calculator, you get 11.97, which just seriously round up to 12. You don't need to give me more than 2 digits on any answer. Otherwise, you could have like 18. I don't really need you to write 18. This is a waste of your time. Just round it up to a reasonable number. Although if you left it at 11.97, I'd give you that. I'd give you the marks for that as well. So basically, here's the trick. Look at the sides you know. Look at the side you want to find. Look at the angle. So opposite is what I want to find. I know the hypotenuse. So opposite and hypotenuse, we use sine. That's the first thing you got to figure out. Then to find the opposite, you multiply the hypotenuse by the side of the angle, and that gives you the opposite side. All right. This is going to seem like a lot, but if you'll notice, it's the same thing over and over and over and over again. We're just changing which one we use, sine, cos, or tan, to find, if you know the adjacent in the hypotenuse, the one beside the angle in the hypotenuse, if you want to find the adjacent, you multiply the hypotenuse by the cosine to get the length. If you want to find the hypotenuse, you divide the adjacent by the cosine. It's exactly the same thing. It's just we're using a different formula now because we know the adjacent and hypotenuse, so we're using the cosine. Here's an example. Look at the triangle. I know the hypotenuse, that's opposite the right angle. I want to find the adjacent side because the angle is 60, so this is the one beside it, so it's the adjacent. So the adjacent is the hypotenuse times the cosine of the angle. So the hypotenuse is 13 times the cosine of 60. Put it into a calculator, you get 6.5. If you know the opposite and the adjacent, you use the tangent. So if you want to find the opposite, it's the adjacent times tan theta. Because again, we cross multiply and that's what we get. If you want to find the adjacent side, you divide the opposite by tan theta. So the only thing really to remember with a lot of these is, are you multiplying or are you dividing? The good thing though is, as I said, with this being online now, you don't even need to memorize this. You just need to have it written out. And you'll always see. You can even write out these instructions for each of them. That's kind of why I gave it to you. Example for that, here's a triangle. What do we know? Well, here's our angle. We don't know the hypotenuse. We don't care about the hypotenuse right now. I know the side opposite to it. I want to find the side adjacent to it. So, if I want to find the adjacent, it's the opposite divided by the tangent of the angle. So, the opposite is 12 divided by the tan of 30. You get that the adjacent side is 21. Then if you wanted to find the hypotenuse, by the way, you could just use Pythagoras to find that, because we knew that already. You know, a squared plus b squared. So the nice thing is if you know one angle and one side for a right angle triangle, you can actually find any of the other sides using these tangents, which is why it's really useful for things like surveying. So the thing to remember is what is the order? And which one do we use? So this is the really important thing to remember. Sine is opposite in hypotenuse. So cosine is adjacent in hypotenuse. Tangent is opposite and adjacent. TOA. So the first thing you do is identify the sides of the triangle, then figure out which thing you're using, sine, cos, tangent, then figure out which one you're trying to find. Once you've got that, here's the math. All right? Good luck. This is one that you are really going to have to practice to get good at doing. It probably makes a tiny bit of sense to probably about 3 of you right now. You're probably going to want to watch this several times, maybe even look at the examples as you're going through. And please don't hesitate to ask for help. Bye.